This is part 2 of AI project cycle. Data exploration is the third phase in AI project cycle. Now, under data exploration, we refer to certain tools, visualization tools, through which we can identify some patterns or trends in the data. Now, what happens when we analyze the data, when we visualize it in some user friendly format? We understand the patterns, and then we can identify what strategy has to be used, and we are also able to communicate the same to others. That is, it becomes easier to picturize. Let us now discuss few visualization tools that we know. Few visualization techniques are: first one is line graph. Now under line graph there is a time interval. Consider sales of a particular item. So this can be the number of units that are sold, and this can be the interval. So here we can depict that in the first year some 2 units were sold, in the second year 4 unit, in the third year 3 units were sold, and this can be used to show the trend of an item over a period of time. Usually, we will have y indicating a numerical value and the x-axis indicating an interval. The next one is histogram. Now, what happens in a histogram is I include some class intervals here, and then if I want to show the frequency, see 10 appears 4 times, and then the range, the data from 10 to 30 appears 8 times, the data from 30 to 45 appears 6 times. So this helps me to understand the distribution of quantitative data. The next is bar graph. Under bar graph there will be some categorical items. There are certain categorical items. So here an example is the games, and here is some numerical item, the number of students. Another example could be, if I want to discuss about the population in various countries, then that can also be a good candidate for a bar graph. Now a pie chart. A pie chart is when I want to show out of the whole how much is occupied by a particular data element, a particular item. So now here consider, if I have, that is, rock occupies 2, paper occupies 3 times, and then scissor occupies 4 times of the data. So this is a total of 9. And then this is how I divide my pie chart. The total area is 100%. Now, this is a word cloud. See, consider if we have a text and I want to understand which are the most common words, then we form a word cloud. In the word cloud, the most common words are the ones that are the biggest. Then, as we can see here, yes and one are most frequently used. Then there is good, state, true, may. All these words are next frequently used, and so on. The next one is a scatter plot. Now, under scatter plot, we have two quantities x and y, and then we draw the correlation between these two. That is, we draw these points. That is, whatever points we have, we plot them against x and y, and then with the help of particular formula and the equations, we get the line of best fit. Now, with this line of best fit, and with the new incoming x value, I will be able to predict the corresponding y value. So now here in this case, x and y show a positive correlation. As x is increasing, y is also increasing. This is positive correlation. Negative correlation will be as one is increasing, the other one is decreasing. That will be negative correlation. And if there is no correlation, then I will get a straight line. Okay, visualization, the two tools are used to formulate information in more meaningful way. See, if I have three options here: chart to show the countries with most oil reserves in 5 years, chart to show the ice cream sales in a year, chart to show percentage of market share of web servers. And I have three options here: bar chart, pie chart, line graph. See, for sales, I might want a line graph. Then after that, to show percentage of market share of web servers, so there might be some, let's say, three or four web servers, and I'm showing the how much it's occupied by each. Like for example, 22% of the market is held by Apache, something like that. So which web server does it? So for this, I think pie chart will be good. And the last one is chart to show the countries with most oil reserves in 5 years. For this, bar chart will be good. Now information is nothing but data in meaningful form. Now, in this case, Dash is not a visualization tool. I know that pie chart, word cloud, map, all these are visualization tool, but paragraph is not, because paragraph is only giving me textual information. There is nothing which I can, if there is long paragraphs, it's not a visualization tool. Database Catalog is a website that explores multiple types of visualization techniques. The next phase is modeling phase. Now, under modeling phase, we want machines to analyze the data, and for that, we want mathematical representation of data. That is, we want to feed in the data to the machine. The machine works on a particular model and it gives me the result. The next important thing to know is AI, ML, and DL. AI is nothing but artificial intelligence. Here, we make computers to think like humans. Artificial intelligence. Artificial means man made. Intelligence is that is, the machine is already trained, and with that knowledge it's applying that knowledge to do a particular task. So the machine is able to think on its own, but in an artificial manner. An artificial intelligent machine works on algorithm and data fed to it and gives the desired output. Now, what is machine learning? Now, machine learning here, the machines will improve with experience. As the machine gets in more data, it will be able to enhance its performance. The next is deep learning. Now, in deep learning, one important thing to know is deep learning is an enhanced version of machine learning. Here, it works with many machine learning algorithms together, and then it gives me a more refined output, a more accurate output. So here, as we can see, artificially intelligence is encompassing the whole. Then there is machine learning. Machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. See, there are many techniques which are coming under artificial intelligence, but out of those, few are getting covered in machine learning. Machine learning also includes several technologies, several algorithms, out of which few get used in deep learning. Now, what is artificial intelligence modeling? Artificial intelligence modeling means we develop certain algorithms, that is, I get some models which are trained, that is, I pass in the training data to them, and after that, the machine gives me the output. Now, the AI models can be either rule based or learning based. So now what happens in the rule based approach? In the rule based approach, the rules are already fed to the machine. The rules are already fed that, consider, if I have several pictures of apple and banana, and then I instruct the machine that if it's a red color and a round object, then it is an apple. If it is yellow and a long object, then it is a banana. Now these rules are already fed to the machine. In the next one, there are several pictures, and then machine itself segregates based on the colors, that these should be fruit 1 and this should be fruit 2. So I'm not labeling anything under the second strategy. The machine does not get anything except for the input. And now the machine has only segregates it, like this should be fruit 1 and this should be fruit 2, and depending upon the output it will develop the algorithm. So, in a rule based approach, there are rules fed to the machine and the machine reacts accordingly. But under learning based approach, the machine is only fed with the data and the desired output, to which the machine designs its own algorithm to match the data to the desired output fed into the machine. An example for rule based approach would be, consider if there are 100 images of apples and 100 images of bananas. So now the machine is fed with that information. When it sees another new image, it now knows if it will be an apple or a banana. There are certain rules given. But in the then I'm passing it testing data and then it identifies it as an apple. Here I'm giving a labeled data set. These are all apples, these are all bananas. Now in learning based approach, there is no labeling that is done. Depending upon extraction of certain features, the machine will segregate. So some random data is fed to the machine and it's left on the machine to figure out patterns and trends out of it. Generally, this approach is followed when the data is unlabeled, when there is no separate category that is there. So the machine looks at the data, extracts similar features out of it, and clusters same data sets together. Let us look at an example. See, there are several pictures of dogs here. And what does the machine do is it segregates pictures of these dogs together depending upon the color. Here the machine has put few images together depending upon the size. So here the machine itself develops a model. Now to form rule based approach, we have decision trees. Now, what happens in the decision tree? In the decision tree, there will be a root node. From the root node, there will be branches, and these branches will have some labels. Then, after that, I will get another test condition. All these are test conditions. I will get some branches again out of those test conditions. See, with that test condition, I may have some results. Those results are only given on these branches. And finally, I will get my answer to this. Am I hungry? Here the example is, am I hungry? If it is a yes, do I have some money? If it is a yes, I go to the restaurant. If I do not have more money, I just get a burger. If I'm not hungry, I go to sleep. Now, important thing to note here is these are the branches. The nodes which do not have children. See, there are five nodes here, okay? This is a node. There are five nodes here. Three nodes do not have children, and these nodes are said to be leaf nodes. So, now if a question is to construct a decision tree, how do I construct a decision tree? First of all, I look at the data, I will decide what will be the root node, and I design the leaf nodes, and then I go about doing the decision tree. Consider if I have some data here. Now, there is outlook, temperature, humidity, wind, and elephant spotted or not. So, there are some four parameters, and my end result is, will I spot an elephant or not? Outlook has three values: sunny, overcast, and rain. Temperature can be either hot, mild, cool. Humidity will be either high or normal. Wind is either weak or strong. Now, the decision tree, for the root node, I can choose anything. For the root node, see all these, the ones that are in gray, all indicate a yes. So, as I can see, if it is an overcast, It's always giving me a yes as the result. So if I form my root node with Outlook, then I will get, with overcast, I will always get a yes. That is, elephant is going to be spotted. Then if it is sunny, then if it is sunny, then that I should check for the temperature. If it is sunny and the temperature is hot, then it is a no. If it is sunny and the temperature is cool, then it might be a yes. So I go about doing it, and finally I get this. See, if it is overcast, yes, the elephant will be spotted. Now, with sunny and the humidity being high, I get a no. That is, no elephant will be spotted. Humidity being normal, I get to see an elephant. If it is rain, if it is outlook is rain, and I check for the wind, if it is strong, it doesn't give me any output, and then if it is weak, I spot an elephant. So depending upon various options that are there, I can go about doing the decision tree. So now, what rules do we form here? If outlook is sunny and humidity is high, then the elephant is spot. Then the elephant is not spotted. If outlook is overcast, then always the elephant is spotted. Another learning-based approach in AI is pixel it. Now here, see, consider I want to identify some handwritten alphabets. So this is a handwritten alphabet. I put it on the grid, and after that I color the grid options wherever there is alphabets, and then I go about joining these, and finally I will be able to identify I'll be able to identify the similar alphabets. The model selected will be evaluated for its efficiency. This will be the last phase of the project cycle, which will be evaluation. Machine learning is a subset of artificial intelligence. Rule based approach uses rules in the form of training data, data set, if else statement. So we saw that our rules were in the form of if else statement. Decision trees solve classification problems where the end result is already labeled. Yes, we saw one example with elephants, and so everything was labeled over there. Yes and no were already given. So this statement is a true. How many test conditions will be there in a decision tree? One, two, sequence of test conditions. Here, many conditions are possible, so the answer will be sequence of test conditions. The approach that is followed in a decision tree. See, in a decision tree, we always start from the topmost node. So it will be top down approach. Dash helps machine to make decision and learn from large data sets. Modeling. AI modeling will help machines to make decisions. All AI models will be either rule based or learning based. In Dash approach, the rules are already predefined. Rule based approach. Dash approach takes input data and compares it with the data set already in the system. So this will be the learning based approach because I'm comparing with what I already have. If the data is not labeled, always remember, if the data is not labeled, then it is clustering approach, and clustering means we follow learning based approach. The number of leaves and branches in the below decision tree are One, two, three, four, five. There are five leaves. One, two, three, four, five, six, seven. There are seven branches.